Hello students, welcome you all in Priyanka Sharma's channel. In this video you will learn about the properties of aqueous medium, how to prepare molar solutions, percent solutions and normal solutions in different types of solutes, for example solids and liquids. So properties of solution, first of all we will define aqueous solution. So aqueous medium, it is a very important and essential medium for nearly all the biochemical reactions takes place in biochemistry, molecular biology, plants and animal tissue cultures and microbial practicals. Therefore it is very important to understand the aqueous solutions and their different components that make the solutions and what is the principle behind for the preparation of different types of aqueous solution. So aqueous solution, it is defined as a homogeneous mixture which is composed by dissolving one or more solutes in a solvent. So now you from this figure you can say solution, it is made up of solvent and solute. Now solute, it is the substance which present in a smaller amount and which dissolved in a solution. For example, NaCl in water. However, solvent, it is always present in a larger amount and which dissolve the solute in a solution. For example, water dissolve NaCl. So water act as a solvent and NaCl act as a solute. As you all know that aqueous solution is the composition of two important components, that is solutes and solvents. Therefore, it is very important to understand the preparation of molar solution by using solutes and solvents. So first of all, we will discuss about the molarity. So molarity, it is defined as the number of moles of solute dissolved per liter of solution. 1 molar is equal to 100 millimolar and it is always denoted by the capital M. And how you will calculate the molarity? You can calculate by applying this formula. So molarity, it is equal to number of moles of the solute divided by volume of the solution in liter, where moles, it is always equal to mass of the solute divided by molar mass of the solute. By computing this equation into the molarity formula, then molarity will be equal to mass of the solute divided by molar mass of the solute into volume of the solution in liters. Thus, the unit of molarity will be moles per liter. Now we are taking some examples to explain how we can prepare the molar solutions for different types of the solutes. First, we are taking the solid solute. The example is to prepare 0.2 molar solution of NaCl in 500 ml solution. So 0.2 molar contains 0.2 moles per liter. As you know, moles, they are equal to grams per molecular weight. Now what you have to calculate here? You know the moles, you have to calculate the grams. So grams, it is always equal to moles divided by molecular weight. And molecular weight of NaCl is equal to 58.4 gram. Then gram will be equal to 0.2 multiplied by 58.4, it is equal to 11.68 gram of NaCl. So 11.68 gram of NaCl, it is the gram of the solute if you dissolve in 1 liter of the solution will give you the 0.2 molar solution. But your question is, you have to prepare the 500 ml of solution. Now we can compute the grams in 500 ml with this equation. 11.68 is required for 1000 ml. Then how much gram of solute is required for 500 ml? Then x is equal to 11.6 into 500 divided by 1000. It is equal to 5.75 gram of NaCl. And this will give you the 0.2 molar solution of NaCl in 500 ml solution. Now we are taking another example, that is how we can prepare 50 ml of 5 molar solution of sodium acetate. In this example, first we are computing the volume. We are considering the volume of the solution, that is aqueous solution. The molecular weight of the sodium acetate is equal to 82 gram per mole. Then you have to calculate the mass of the solute. Mass of the solute is equal to molecular weight into volume of your solution. So volume of solution is here 50 ml. Then you have to divide by the 1000 ml. As you know, 1 molar is equal to what? Molecular weight in 1000 ml. Then it will equal to 4.1 gram. Then you have to prepare 5 molar solution. So 4.1 gram in 50 ml gives you 1 molar. You have to multiply 4.1, how much you require to prepare 5 molar, then you will multiply 5 times and you will get 20.5 gram of sodium acetate. When you dissolve this much gram in 500 ml, you will get the 5 molar solution of sodium acetate. So by taking two examples, I think it's clear to all of you. Either we can take the mole of the solute or volume of the solution. Then later on we have to compute the second terms for preparation of or required concentrations. Now take the example for molarity of liquid solutes. In previous examples, we prepared the molarity for the solid solution by weighing the solutes. Now, as you all know, the acids, they are always comes in the form of liquid, HCl, H2SO4, nitric and some H2O2, etc. For preparation of molarity in liquid solutes, you have to calculate or you have to follow certain steps. So first you have to calculate the molecular weight of the solute, then calculate the molarity of that solute by applying this formula. Molarity is always equal to percentage of purity into density into 1000 divided by molecular weight into 100. So why we are taking percentage of purity here? Because in all these acid bottles we get the number of solutes, means you are getting the gram of the solute, you are not getting the moles of the solute. That's why we are considering the purity of the percentage of purity, means if on your bottle it is mentioned as 37% purity, so 37 part of your solute is present in 100 parts. That's why we divided here with 100. And density, it is always mentioned as a specific gravity on your bottle, and 1000, it is the 1 molar solution in 1 liter divided by molecular weight. So after calculating the molarity of your bottle, you will calculate the volume of the solute required for preparation of required concentration. For example, a 1 molar solution. So this you can calculate by applying the dilution equation. That is C1 is into V1 is equal to C2 V2. C1 is the concentration of concentrated HCl. V1, that is how much volume you will take from the concentrated bottle to prepare the concentration of C2. So C2 is here 1 molar, and V2, how much solution you have to prepare, for example 100 ml. So let's take next how you will prepare 0.1 molar solution of liquid solute by finding the volume of that bottle. So first of all, apply the formula molarity. Molarity, it is number of moles of the solute divided by volume of the solution in liters. And as you all know, number of moles, it is equal to mass of the solute in grams divided by molecular weight of the solute. Then your molarity will become as the mass of the solute divided by molar mass of the solute into volume of solution in liters. Since you know HCl or other acids, they always comes in the form of liquid. So that's why we don't weigh out and we need to find out the molar solution by taking specific volume of the acid. Clear? Then mass of the solute is equal to molarity into molecular weight of the solute into volume in liter. As you know, mass is equal to volume into density. So if you put this equation in previous equation, then it will become volume into density is equal to molarity into molecular weight of the solute into volume in liter, and rearrange this whole equation, you will get the volume is equal to molarity into molecular weight of the solute into volume in liter divided by specific gravity or density. And now you have to consider the purity of your solute, because these liquid acids, they always comes in the pure, they are not as 100% pure. So for example here 34% purity, 34% purity means 34 parts of your gram is the weight of your solute in 100 part, into volume is equal to molarity into molecular weight of solute into volume in liter divided by density. And volume is equal to, now if you arrange this equation, molarity into molecular weight of the solute, volume in liter into 100 divided by density into purity. So now take the example, prepare 1 molar and 0.5 molar HCl in 100 ml. So if purity on your bottle mentioned is 34% and specific gravity or density mentioned as 1.18, and you know the molecular weight of HCl is 36.5. So by applying the formulas which we discussed right now, the molarity of HCl is always equal to 10.9 moles per liter if the purity is 34. In some bottles it comes at 36% or 37%. Then by using the dilution formula C1V1 is equal to C2V2, C1 is the molarity of HCl, that is you have calculated 10.99. V1 the volume which you will take from this bottle, concentrated bottle, and C2 it is you have to prepare, that is 100 ml, and V2 is the C2 it is the concentration that we have to prepare, that is 1 molar and 0.5 molar, and V2 it is the required volume, that is 100 ml. Therefore the volume we will take from the concentrated HCl is 9.55 for 1 molar and 4.83 ml for the 0.5 molar respectively in 90.55 and 95.15 ml distilled water. So your total volume should be 100 ml, should not be beyond the 100. So first you have to take the volume of acid from the concentrated bottles, then make a total volume to 100 ml. Next solution that mostly you have to prepare in your practical, this percent concentration. Percent concentration means the parts of the solute per 100 parts of total solution. Clear? So these percent concentrations are usually we express in three different forms: weight per unit weight, weight per unit volume, volume per unit volume. So first we are taking weight per unit weight, and it is expressed in grams of solute per 100 gram of the solution. 10% weight by weight solution of NaOH means 10 gram of NaOH to be dissolved in 100 gram of water. Then volume per unit volume means it expressed in milliliters of solute per 100 ml of the solution. So 1 ml in 100 ml. If you are going to prepare 5% of solution of alcohol, it means in 100 ml of solution 5 part of alcohol will be added. So you will take 5 ml from the alcohol bottle and rest you will add 95 ml and make it 100 ml total. Then third expression is weight per unit volume, which is generally we used in practical time. It is expressed in grams of solute per 100 ml of the solution. 2% solution of KOH means 2 gram of NaOH will be dissolved in 100 ml of solution. So if solution of specified percent concentration may be prepared, we use the mass of the substance. So whenever you are preparing the percent solutions during practicals, or you are getting some problems how to prepare the percent solution, you will consider the weight of the solute, you will consider the mass of the solute, not a chemical formula or molecular weight of your solute, because percentage means that part in 100 ml, molarity means moles in 1000 ml. So you will not consider the molecular weight in percent solution preparation. Understood? So next solution is the normal solutions, and the concentration of the solution could also be expressed in terms of the normality. The normality of solution is defined, it is the concentration expressed as the number of equivalent weights of solute per liter of solution, and it is based on the alternative chemical unit of mass called equivalent weight. And since normality simplifies the calculation required for chemical concentration, which is widely used in analytical chemistry, So in a chemical mixture, one normal solution always contains one equivalent weight of solute per liter of solution. Understood? So in normal solution preparation, we consider the normality of the we consider the equivalent weight of the solute. So now what is the formula? How you will calculate the normality of particular solute? So number of equivalent weights divided by 1 liter of solution means if you are dissolving the number of equivalent weights in 1 liter of solution, you will get the one normal solution. Now what do you mean by the number of equivalent of solute? So number of equivalents is equal to weight of your solute and equivalence weight. So equivalent weight is number of equivalents is equal to weight of the solute, equivalent weight. So equivalent weight now, it is the molecular weight of the solute divided by N. Understood? Normality, number of equivalents of solute in 1 liter. So how you will calculate the number of equivalent solute? Number of equivalents is what is the weight of your solute divided by equivalent weight, and equivalent weight, it is equal to molecular weight of solute divided by N, and it represents the number of replaceable hydrogens in case of acids and hydroxyl ions in case of base per molecule. For example, H2SO4. So number of replaceable hydrogen H2, 2, and if you are taking NaOH, NaOH is the base, so OH is replaceable hydroxyl ion and it is 1. That is your N, means equivalence, valency, and N represents the number of electrons gained or lost per molecule due in oxidizing and reducing agents. This is the one way we can calculate the normality by taking the number of equivalents, and there is another way to calculate the normality if you know the molarity of that solution. In previous slides we have discussed how we can calculate the normality of HCl, H2O water. If you know the molarity, then simply apply this equation. N is equal to capital N is equal to small n multiplied by molecular weight, and N, small n, as you know, number of replaceable hydrogen ions and hydroxyl ions. So for example, 0.1 molar solution of H2SO you want to prepare is equal to what? 0.1 molar solution. So you know the molarity of the solution. Now normality is equal to, in H2SO4 your N is equal to 2. So this N is equal to 2, and 2 into 0.1 is equal to 0.2 molar. Let's take an example for calculation of normality. What is the normality of H2SO4 solution that contains 24.5 gram of solute in a total volume of 100 ml? The formula for normality calculation is capital N is equal to small n into molarity, that is capital M. So now in this case, first you have to calculate the molarity. So molarity, it is equal to number of moles divided by volume in liter. And as you know, number of moles is equal to weight of the solute divided by molecular weight. So given weight of solute is here 24.5 gram and molecular weight for H2SO4 is 98 gram. Then number of moles will be equal to 24.5 divided by 98 is equal to 0.25 moles. Now the required volume is 100 ml. Then you have to calculate the volume. 100 ml is equal to 100 divided by 1000. Why we divide here with 1000? As you know, 1 molar solution is equal to molecular weight in 1000 ml. That's why we divide here with 1000, and then it becomes as a 0.1 liter. Now the molarity is equal to number of moles divided by volume in liter, and number of moles you calculate here, that is 0.25, and volume 0.1 liter, it will give you 2.5 molar. Now compute this value in the equation number 1, that is capital N is equal to small n into M. Now small n, as earlier I told you, is the equivalent valency. So equivalent valency in H2SO4 is replaceable hydrogen, that are 2. So multiply 2 into 2.5 will give you the 5 molar solution. So it's clear how we can calculate the normality of the solution. First we have calculate the molarity of the solution by taking the weight of the solute and molecular weight of the solute. Then we have to calculate the volume of the solute as per the requirement of your solution. Understood? So there are some examples for your self practice. Try at home and by applying all these formulas. So thank you very much for listening this video. If you like this video, please subscribe and share it.